Hello, ladies and gentlemen. Welcome once again to our virtual classroom. And today we are going to be going over classifying rational numbers. At this point, if you haven't done so already, I encourage you to pause this video as you take out your physical notebook and you write this down, classifying rational numbers. And to make it easier to read, let me type this up. Classifying rational numbers. Okay, there you go. Now, this is our 15th lesson. If your numbers are a bit off, just make sure that this is the 15th lesson because any other resources that you find, they are going to be numbered according to the lessons that I have. And so if you misnumbered something, just know that this is supposed to be the 15th lesson. And again, we're talking about classifying rational numbers. Now, as we begin, I want you to remember that every single number that we're going to cover in this specific lesson is a rational number. Now, we're going to classify those rational numbers, in other words, categorize them or put them into different categories. But regardless, all of the numbers and all the different types of numbers that we're going to be talking about are rational numbers. Okay, in fact, most of the numbers that you have used since you were in elementary school have been rational numbers. Now, we're not going to define what a rational number is yet because there's still a few other things that we need to learn in order to make sense of that definition. But for now, just understand that the numbers that we're going to be looking at this lesson, regardless of how we categorize them, do not forget that all of them fall under the umbrella of rational numbers. All right. Now, the first and arguably the most important group of numbers that we're going to be talking about today are known as integers. Integers. Oh, sorry about that. Integers. And ladies and gentlemen, and again, I encourage you to pause the video from going too fast as you copy this down into your notebook, unless you're just reviewing your notes. Now, an integer is simply, or integers are numbers without a decimal value. Numbers without a decimal value. For example, consider the number 8. Okay, 8. Now, remember what we've talked about before. Numbers have decimals. 8 is the same thing as 8.0, except that this is redundant, meaning we don't need it because that has no value. That's why we typically write it just as 8. But it does have a decimal. It's right here. And that's the same thing as 8.0, which is the same thing as 8.00, which is the same thing as 8.000, meaning there is no decimal value. All right? This is all that really matters as far as its magnitude, its value. So therefore, 8 is, as it is, 8 in the ones place, that is an integer. 8 is an integer. It does not have a decimal value. 8 is an integer. Now, if it was 8.1, now it does have a decimal value, so that would not be an integer. 8.009, again, it has a decimal value, so therefore that would not be an integer either. Okay, so integers are rational numbers that do not have a decimal value. So a number without a decimal. A number without a decimal value. All right. Now, it's important to know that integers can either be positive or negative. Now, if you don't know what a negative number is, or you're not really familiar with them, don't worry about it. We're going to cover that more in depth. But again, don't pay attention to whether it's positive or negative at this point. Pay attention to whether it has a decimal value or not. For example, -7. -7 has no decimal value. It's the same thing as -7.0. No decimal value. Therefore, it is an integer. This is an integer. Another example up here, we have -81.0. Same exact scenario. There is no decimal value. It doesn't matter that it's negative. It has no decimal value. Therefore, it is an integer. What about some positive numbers like 32? Again, 32 is the same thing as 32.0. It has no decimal value. That 0 doesn't make it larger or smaller. So therefore, it is an integer. It has no decimal value. It is an integer. A larger number, like 10,754. Again, it's a positive number, no decimal value. There's nothing of value after the decimal. You can go on forever. No decimal value, therefore it is an integer. Okay, so in short, an integer is a rational number, is a number without a decimal value. Okay, now within integers, ladies and gentlemen, we have a special group of numbers. So these are still integers. We're still talking about integers. These integers, however, are known as whole numbers. Integers, these integers are known as whole numbers. And whole numbers are simply positive integers. So if you have an integer and that integer is positive, that makes it a whole number. Like the number 8 that we just saw, like the number 32, like the number 10,754. All of those previous examples, in fact, I was putting them in green for a reason, because they are, not only are they integers, but they are positive integers, which makes them whole numbers. So whole numbers are integers that are positives. Again, because they are integers, they have no decimals. And aside from positive integers, these whole numbers, this includes the number 0. The number 0. 0, even though 0 is technically neither positive or negative, 0 is considered the smallest whole number. So if I were to make a chronological list of whole numbers, I would start with 0, followed by the number 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then etc. Hope I've made my point very clear. It goes on forever. Just think of these as counting numbers. Anytime you're counting whole things, how many people are in the room? You don't say 3.75 people are in the room. No, it's 3 people, 8 people, 100 people. There are 5,000 people, etc. It's a whole thing that you're counting. So again, integers are rational numbers, and they are numbers without a decimal value. Okay, they don't have a part attached to it. It's just that number, and they can be positive or negative. However, the positive integers are known as whole numbers. Very well. Moving on. Next, let's talk about rational numbers. So we talked about integers. Those are rational numbers without a decimal value. But now let's talk about rational numbers that are not integers. Non-integer rational numbers. Non-integer rational numbers. Okay? So if integers do not have a decimal value, then non-integers do have a decimal value. Okay? Think of something like negative 7.2. It does have a value after decimal. Negative 8.0107. It does have a decimal value. 0.1. It does have a decimal value. All right? Anything that has a decimal value is not an integer. What else is not an integer? Fractions. Specifically, think of proper fractions like 1/2. 1/2 is the same thing as 0.5. Later on, I'll show you how to go from this. In fact, you just divide. 1 divided by 2 will give you 0.5. There's a decimal value. 3/4. Again, if you divide it, that makes into a decimal, which is 75 hundredths. It has a decimal value. Mixed numbers. 6 3/4 is the same thing as 6.75. Notice how it does have this mixed number, where I'm mixing a whole number and a fraction. It does have a decimal value. 2.5, that's a mixed number, is the same thing as 2.5. Again, it has a decimal value. So anytime we have decimals, fractions, meaning proper fractions, and mixed numbers, those are not integers. Now this last one is more of a, it's typically speaking, percents are not rational numbers. I'm talking about things like 71%, 71%, or 62%, or 3%, or 207%, okay? Later on, I'll show you how to change percents into decimals, but 71% is the same thing as 71 hundredths. Again, it does have a decimal value. 62% is the same thing as 62 hundredths. Again, it has a decimal value. 3% is the same thing as 3 hundredths. Again, decimal value. 207% is the same thing as 2 and 7 hundredths. Again, it does have a decimal value. So anytime, ladies and gentlemen, that we have something that could be expressed as a decimal value, it is not an integer. So integers, no decimal value. It's just the whole number. And if they're positive, then we call them a whole numbers, right? So integers, positive or negative, as long as it does not have a decimal value. Non-integers, things like decimals, fractions, mixed numbers, and percents. All right? And that's how those things are constructed. All right. So with that in mind, ladies and gentlemen, let's actually go through the assignment. Let's go in here. Let me just open it up. Okay, let me share my screen once again. That's not it. There we go. Okay, so looking at the assignment for today. All right, so we're given 7 different numbers, beginning with 3.4, followed by 7, 5.5. And we're tasked with identifying whether these numbers are rational, and if they are rational, are they whole? Or if they're not rational numbers, if they're not integers, what kind of rational number are there? For example, 3.4, 3 and 4/10. It does have a decimal value, so it's definitely not an integer. So I'm just going to call that a decimal. So I'm going to put in blank 1, and I'm just going to find the word decimal right here. And there it is. It's a decimal. It's not a rational. It is a rational number. Sorry, it is a rational number. It's not an integer. It is not an integer. Very good. Let's talk about the number 7. So for number 2, we have the number 7. So in essence, guys, when you look at these numbers, ask yourself, does it have a decimal value? Okay. 3.4, it did have a decimal value, so it wasn't an integer. 7 has no decimal value. It's the same thing as 7.0. There is no value there. That's why we just write 7, no decimal value. Therefore, it is an integer. So number 7, which is blank 2, notice how that's number 2 actually. It is an integer. And not only is it an integer, notice how there's no second blank right here, but because it is a positive integer, it is also a whole number. So number 2, which we're talking about number 7, is an integer and a whole number. Number 3, 5.5. That is a mixed number. Just by looking at our notes, we saw that mixed numbers are not integers. So I'm just going to call it what it is. It's a mixed number. Number 4, 91%. Again, we just talked about percentages. Typically speaking, percentages are going to yield a decimal value. This would actually be 0.91. So therefore, it is not an integer. And I'm just going to call this a percent. Number 5, which is blank 6, as you can see. Number 5. We have a negative 8. Does that have a decimal value? No. So it is an integer. It is an integer. It's not a whole number because it's negative. Remember, whole numbers have to be positive, but it is an integer. It doesn't have a decimal value. Blank 7, which is number 6. We have 22. All right, 22.0 to be exact, which kind of gives it away. There is no decimal value. Of course it has a decimal. All numbers have the decimal, but there's no decimal value. Therefore, it is an integer. No decimal value makes it an integer. Not only is it an integer, but it's a positive integer, which makes it a whole number. And finally, number 7. Now be careful with number 7. We have 21 sevenths. Now, I'd be tempted to put this as an improper fraction and just kind of writing it like that and maybe changing it into a mixed number. But remember what the fraction bar means. That means division, right? So let's divide 21 by 7. 21 divided by 7. Wait, isn't that 3? So as you can see, this is a bit of a trick problem, isn't it? Because if 21 over 7 is equal to 3 wholes, notice how that does not have a decimal value. Therefore, it is an integer. Not only is it an integer, but it's a positive integer. Therefore, it's also a whole number. It's an integer and a whole number. All right? So as you can see, I have filled out this table. And hopefully this was just a good practice, a good introduction into what rational numbers are, specifically what an integer is and what is not an integer. Okay. Hope you found this helpful, ladies and gentlemen. I hope you did your submission and you submitted that, and I will be seeing you soon. Have a good one.